Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving a problem, best team with no conflicts. So in this problem, we are the manager of a basketball team, and for the upcoming tournament, you want to choose the team with the highest overall score. The score of the team is sum of scores of all players in the team. However, the basketball team is not allowed to have conflicts. A conflict exists if a younger player has strictly higher score than an older player. A conflict doesn't occur between players of the same age. Given two lists scores and ages, where scores of I and ages of I represents the score and age of the ith player respectively, return the highest overall score of all possible basketball teams. The important point to note here is when does the conflict occur? The conflict occurs when age of I is less than age of A, I is younger than J, and score of I is greater than score of J. I scores more than J. Then I and J cannot be in the same team because conflict exists between them. So in order to have no conflict, we should have score of I less than or equal to score of J. So if age of I is less than age of J, score of I should be less than or equal to score of J. Then we can consider both the players into our team. And we have to find the players. We have to take the players into our team such that there exists no conflict between any two players. Okay. So in order to take the players, we should have this condition and this condition. Both the conditions satisfied. The age should be less than and the score should be less than or equal to between two players. So to check that, we have to check these two conditions, right? We can make one condition default by sorting based on, if we sort based on the age, let's say, what we can do is we can consider a 2D list of players where player of I will be age of I, comma, score of I, and then we sort the players based on their ages. If we sort this players array, it by default sort the players based on their ages, then this condition will automatically be true. If we execute, if we iterate from left to right, this condition will automatically be true. The before person's age will always be less than the next person's age, less than or equal to. Okay, so this condition we don't have to check now. We only have to check this condition. Let us sort these. Let me take this example. We have 1 2 1 2 1. If we sort, it will be 1 1 2 2, and then the scores will be, so first one has 5, second one also has 5, so this will be 5 5 and 4 4 6. If we sort the players, they will be like this. The first player has age 1 and score 5. So the ages are in increasing order. So this condition will be true always. Now what we have to do is we have to find the players such that score of the ith player is less than or equal to score of the jth player. So this 5 should be less than or equal to this 5. Then we consider these two players. Does this remind you of any other problem? What we are doing here is we are finding subsequence of players where their score of I is less than or equal to score of j. In the problem, longest increasing subsequence, what we find the subsequence of numbers where the number of I is less than number of j. So this is strictly increasing. This is the variation of the longest increasing subsequence problem where we have less than or equal to. So what is the next step? We can apply longest increasing subsequence to scores and find the or take the subsequence of players with highest scores. Okay, so let's see it in code. Firstly, we calculate the number of players, scores dot size, and then we can have a vector of int. Let us create a 2D list of players and let us iterate over the scores and ages and add them into the players. So players dot pushback of, first we push ages because we want to sort based on the ages. Then so scores of I. Now we have created the 2D list. This step is done. Next we have to sort the players based on their ages. If we sort, it will sort by default based on the age only. So let's sort players dot begin, players dot end. Now we have completed the second step also. Now we have to apply longest increasing subsequence. So for that, let us have a DP array. DP size will be n, and what we do, we start from j equal to 0, j less than n, j plus plus, and now dp of I, we can consider a single player always, right? So the dp of I initially will be score, not score of I. We sorted, so we have to consider players of I of 1. So we can always consider one player. So we consider the player's score. Next, we iterate from starting position to j and I plus plus. Now, what we have to check? We have to check this condition. Score of I should be less than or equal to score of j. If players of I of 1 is less than or equal to players of I j of 1. If ith player score is less than or equal to jth player score, the age is already in ascending order, so we don't have to check the age, we only check the score. And if this is the case, then the dp of I, this is dp of j, because firstly we took j, right? Dp of j will be equal to dp of maximum of dp of j comma dp of I plus scores of j1, jth players of j1. So this will be score of jth player. All this is same as the longest increasing subsequence code. We only have changed this operation only, and we also have to calculate the maximum score, the highest score. Let's initially make it 0, and the maximum score equal to maximum of max score comma dp of j, and finally we return max score. Looks good to me. Let us run and see if we have any errors or it passed all the test cases or not. We have an error. Okay, this is ages. Let us run the code now. It passed all the sample test cases. Let us submit it. It passed all the test cases. So let us discuss the time and space complexity. Here we are creating. So this loop will be O of n. And here we are sorting them. So it will be O of n log n. And here we are iterating over the players twice. So we have two nested loops. We are iterating over the players twice. So it will be O of n squared. So the overall time complexity is, here we have O of O of n plus O of n log n plus O of n square. So the maximum will be O of n square. So O of n square will be the time complexity, and what will be the space complexity here? Space complexity here we are considering a DP array and a players array, both of length n. So the space complexity will be O of n. Time complexity is O of n square and space complexity is O of n. So I hope you understood today's problem, and this problem is this problem covers two topics. One is greedy and second one is dynamic programming. So what interviewers do in interviews is that instead of directly asking the longest increasing subsequence question, they ask the variation of longest increasing subsequence questions like this question. So you have to practice the basic questions first, standard questions first, then you can solve any other problem with ease. I hope you have understood today's problem. If you did, make sure you hit that like button and subscribe Coding Charms for more daily problem solving content. And see you all in my next video. Till then, keep practicing, keep coding, keep learning. Take care. Bye-bye.